Everyone, Ismail is here. Today we're going to learn 1.5 parent functions and transformations. You can find this lesson on pre-calculus subject for the McGraw-Hill. Now, 1.5 parent functions and transformation. This lesson is a big lesson which is summarizing all type of functions that you studied in integrated math 1, 2 or 3, or if you're studying an algebra or geometry things. Okay, now to summarize everything and make it easy to all the students, first thing, let's have a look on the vocabulary words. Okay, look to the vocabulary. First thing that we need to know here is the parent function. Okay, what is the parent function? Parent function, it's the main function. It's the function that without any transformation, without any translation, without anything, which is we call it, let's say, the original function. Okay, we will go through this one later. Then we have constant function, which is only numbers. So if I have, let's say, y is equal to, so constant function is just it's a straight line always. Okay, so this is like a straight line. This is the constant function. Then we have the zero function. The zero function means when you have zero function, which is zero. It's from its name. You can understand it. Then we have the identity function. We have the quadratic function, the cubic function, square root function, reciprocal function, absolute value function. All of these functions we are going to go through on every one of these. But let's start now with the first one, which is we call it identity function. Okay, so what is identity function? It's another name of the linear function. You know now the linear function. Okay, linear function. Okay, so you know that identity function is another name of the linear function, and you know that the linear function is just a straight line. Let's say summarize it here, or let's make a table for you. Okay, so the first thing, all of those that we are going to explain are the functions. So now the first function here is the linear function. Okay, now what is the formula for the linear function? The formula for the linear function is y equal mx plus b. Okay, and the linear function is just from its name, or the identity function is just a straight line. So if I have the coordinate, okay, y and x coordinate, so now the linear function, it's always start from like this one. So as you can see, this one is increasing function when the slope, okay, is positive. Okay, and when the slope is negative, it will be it's like decreasing function. So this one, when the slope is negative. Okay, if you look to the function here, mx plus b, m is represent the slope for the function. If it's positive, it will be in the red one. If it's negative, it will be in the yellow one. Then we have b, which means the y-intercept. Where is this intercept? Where is this line intersect or intercept with the y-axis? Okay, so this is the linear function, more basic, or identity function, the easiest one. Okay, now after we know the linear function, let's go to another function here. So this function, the linear function, it's only x. So this is the parent function. Parent function is only y equal x. Now the second one is, we call it quadratic function. Okay, a quadratic function. Okay, or we can call it as a parabola. Here we say the quadratic function. Okay, now what is the quadratic function means? Quadratic function, it's just like a parabola. First, let's start with the formulas. So we have 3 formulas for the quadratic function. The first formula is, let's call it the standard form. So the first form is the standard form for the quadratic, ax squared plus bx plus c. So this one we call it, let me write here. Okay, this one is the standard, okay, standard form. Okay, now the second form of the quadratic is the vertex form, or the graphing form, x minus h to the power of 2 plus k. So this one here is the vertex form. We call it vertex or the graphing form. And this one, the vertex form, is more easier to graph any quadratic because you know the center from h and k. The third one, which is not common for all the students, we call it intercept form, x minus p, okay, and x minus q. What is p? What is q? Is any value, any numbers. Okay, so now as you can see, we have 3 forms of a graphing quadratic: the standard, the vertex, and the last one is intercept form, or the factored form. We call this one intercept or a factored form. So now the quadratic always can be graphed as U letters. You know that the U letters always, let me do it here for you. So let's say this is Y, this is X, okay, and the quadratic, it's always like a U letters. This one is the quadratic, the vertex, this one, okay, 0 0, and this one is represent H, and this one is K. Okay, so this is the quadratic one, and it's upward. We can graph it as upward when A is positive. Okay, so do you see this term A? When A is positive, so it will be upward. Okay, and how about when A is negative? When A is negative, it will be like downward. So start from the center, vertex 0 0, so it will be downward. So A is negative, so it will be downward. Okay, and the same thing, the H and K will be 0 0. Now, what is the standard or the parent function for the quadratic? The parent function is x to the power of 2. So this is the standard form. Okay, let me give you more additional information about the quadratic, how we can graph the quadratic. Okay, if the question given, let's start with number 1. If the question given in the standard form, first thing you need to find h. How you can find h? Okay, h is, this is the formula you have to memorize, to negative b over 2a. This is the formula that you can find h. After you find the value h, you need to find the value k. How you can find the value k? Replace h in the formula, okay, in x here, because h is represented as x. Okay, so replace it in the k, which is in the, replace it in every x. So it will be b, okay, plus c. After that you can get k. Then you can make the table x, y. In the middle of your table will be k and h, that you get it from here and from here. Then pick 2 points less than, pick 2 points greater than. So this is how you can graph it when it's in the standard form. How we can graph it using the vertex form? Vertex form is easy. You have h, you have k, so you have h and k from the formula. So now start make table directly. So in the middle of your table, you just put h and k, pick 2 points less than h, pick 2 points greater than h, then you can graph the parabola using the vertex form. One more time, or let's say one more graphing for when it's in that intercept form or factored form. So how you can factor the form? We know that the x's here represent the x-intercept. So the first thing, x is equal p, just take the opposite sign, and this is x1, and x2 is equal q. So now we know that on the graph we have x1, okay, and we have here x2. Now the only thing, you know that it's a parabola, so I need just to know the only thing, where is the midpoint, so I can complete my parabola. So what can I do? Just find like an average. So it will be, now the k, it will be p plus q divided by 2, then you can find k, okay, which is axis of symmetry. Now you can just replace it, and you can graph the function. So this is just additional information how you can graph the quadratic formula, okay, using any of the form. If you need help, please ask me in the comments. Now the third one is the cubic function. What is the cubic function? It's x to the power of 3. Okay, now cubic function has also two formula that we can use to graph. So the first one is y equal ax cubed plus bx squared plus cx plus d. So we call this one as a standard form. And what do you think will be the vertex form? The vertex form will be x minus h to the power of 3 plus k. So as you can see, this one is the standard form, okay, and this one here is the vertex form. And if you notice, between the cubic function and the quadratic function, they are sharing the same standard form, okay, except we start here for the cubic from x to the power of 3, and here we start from x to the power of 2. Same thing for the vertex. If you look to the vertex, they have same vertex, except the power here is 2, but the power here is cube, which is to the power of 3. So what do you think if we need to graph the cubic root? We can do. Okay, first thing, let's before we start graphing, we need to know how the sketch look like, how the graph of the cubic root look like. So the graphing of the cubic root, it's look like this one here. It's like something small, curvy from left to right and from down to up. Okay, so this one here, it's when A is positive. Okay, when you check A, when A the value is positive, so the graph, it will look like this one. It's a start from down left, okay, to up right. Okay, and we can say that it's start from up left, okay, and goes down right. So this one when A is negative. Okay, so we just switch between them. Now after we know this, how we can graph the cubic function? It will be same as the quadratic. We know that we're using the vertex. Okay, so let's use the vertex h and k. We have h and k. Then we can make a small table. Okay, and h and k should be in the middle. Then after that we pick 2 points less than h. We pick 2 points greater than h. We can then graph the cubic function. Okay, so now this is the type of function of the cubic. Now after we know the cubic, the next one here that we are going to study is, if we go here, okay, we finish the cubic, it's the square root function. Now what is actually square root function? Okay, square root, from its name, it's a square root, right, which is root. So let me write here, square root function, square root function. So what is the formula for the square root function? So the formula for the square root function is y equal a square root x minus h plus k. So this one is the formula to graph any square root function. And the same thing, okay, of the graphing, h and k means the vertex or the center of your graph, and the graph for the square root is always start from 0 0 and goes like this one. It's like someone swimming, okay, or someone flying. So this one is the square root function. Okay, and what if a is negative? Okay, because this is square root here, this is graph when a is a positive value. But how about when a is negative? So a is negative, we just cross the y-axis, oh sorry, the x-axis. So as you can see, this graph here when a is negative. And how we can graph the square root function? The graphing square root also, it's easy. So the first thing, you can identify h and k. Same thing. What is h and k? H and k is here. Okay, then you can just pick any random point between h and k, but the table will start from h and k. Okay, h and k will be the beginning, and next the second point will be 1 and 1. Okay, maybe someone will tell me, teacher, is not 1 and 1. Okay, I will tell you why I said 1, it's 1. Okay, perfect. First, because here, if you look to the graph, a is always represented as the vertical stretch or vertical compression. Okay, vertical stretch or vertical compression. So how can I know a? So let's say if I have 2, okay, a is equal to. Now when I need to graph my function, I will start, let's say it's all starting from 0 0. Okay, the second point should be 1 and 1. Okay, but because a, okay, this is 1 and this is 1, but because a it's 2 here, so that's mean it's saying vertical. Vertical means y-axis, so I have to go 2 steps up and 1 step to the right, okay, to graph the function. Okay, like, sorry, let me graph it here like this one. Okay, look to this one. Okay, here let's say I have this example, y is equal 3 square root x minus 2 plus 4. Okay, so now the original function, let me graph the original. The original, it starts from 0 0 and it's 1 and 1. I put point here, then it goes like this. So this is the original function, this is the parent function, square root of x. Now if I need to graph this one here, first I have to identify h and k. What is h and k here? H and k is 2 and 4. Why I take 2 not negative 2? Because always for h you take opposite sign, and k you take the same sign. This is a rule, just keep it in your mind. Always h should be opposite sign and same sign for the k. So as you can see, it was negative 2, so it's 2 and 4, it will be 4. Now the center, it will be 2 and 4, so this is 1, this is 2 and 4, this 1 2 3 and 4. Okay, so now 2 and 4 should be here. Okay, now as you can see, you know that the A should be 1 up 1 to the right. Okay, 1 up 1 to the right, so I have to go 1 up 1 to the right. But if, as I told you, A is the vertical stretch, so when I need to move 1 up, I will not move 1 up, because here the question tell me that A is a 3, so I have to move 1 2 3 step up 1 to the right, so the second point will be here, so the graph will be like this. So this is how we can graph the cubic function. We look to the A and we see if we have a vertical stretch or vertical compression, then A will be represent as the vertical steps. Okay, how about if I have, let's say, the same example, but let's change 3 and we write, but instead of 3 I write 1 over 2. 1 over 2 means 0.5, so I know that rather than going 1 step to up and 1 step to the right, I will go half a step only, okay, and 1 step to the right. So I will go half a step up and 1 step to the right. Okay, I hope you got the idea for this one. Okay, let me try this one back, 2 3. Okay, so this is the square root function. Okay, now the square root function, we have 4 graphs that we can graph the square root of function. Means, okay, let me just show you the square root. So the first square root, it's starting from 0, go to this one. So this is when A is positive. Okay, now when the graph it goes down, okay, the function will be negative. Okay, when the graph it goes all reflected over the y-axis, means it's negative x. Okay, but when the graph it's reflected over the x-axis, and which is reflected by origin, so it will be, both of them will be negative. Maybe someone will ask me, teacher, okay, how did I get negative under square root? We can't have a negative under the square root. I will say, yes, you're correct, we can't have a negative. But now focus with me. If I replace x with negative numbers, let's say if x is equal negative 1, and if I write here square root negative with negative 1, so now negative with negative become what? Become positive. So the answer is what? Is 1. So sometimes we can have a negative under the square root, but we can't, let's say if the value of x is negative, if the value of x, we can get this function. But if the value is positive, so this function will be undefined. Okay, now after the square root function, we have the next coming function, which is we call it reciprocal function, or also there is another name for the reciprocal, which is called rational function. Now rational functions, it's from its name. Okay, let me go to the left side, so I have some spaces here. Okay, so now let's go to this side here. So let's call this one rational function, rational or reciprocal function. What's the rational function? Rational function, this one is the parents, 1 over x. Okay, and 1 over x, and as you can see here, 1 over x always, if I replace x with 0, so I can get 1 over 0. If you did 1 over 0, can you divide any number by 0? You can divide any number by 0, so because now it's you, if you have, let's say you have $1 and you need to give this $1 for a 0 person, you can't give $1 for a 0 person, so that's why it's undefined, that's why it does not exist. So now the graph of the rational function, it will be like this one. Okay, so now the first quadrant, this one here, okay, this is a quadrant 1. Okay, the left side is a quadrant 2, this one is a quadrant 3, this one is a quadrant 4. So as you can see, we have 4 quadrants to graph the rational function. But in which quadrant the rational function will be? Always the rational function will be in quadrant 1, and it will be in quadrant 3. Always, okay, only in quadrant 1 and quadrant 3, except if A is negative. But now focus on rational. So the rational always can be graphed in quadrant 1 and the quadrant 3. How the graph will look like? Okay, the graph will be like someone, okay, like this, and the other one be like this. So as you can see, one like this, one like this, or we can say it like this. Sorry. or like this. Okay, so it will be like two fishes against each other. So as you can see, the graph will be like this, and it goes like this one, or the graph will go to the left and goes down. So always the 1 over x, it's look like this one here. Okay, now what is the formula to graph the irrational function? The formula is y equal, from it's the parents, we take the parents. So first we start with a multiplied with x minus h plus k. Always h is related to the x and always opposite side. Okay, so this graph here when a is positive, so this one when a is positive. How about when a is negative? Okay, when a is negative, let me graph it here. When a is negative, we have to graph using this one here. Okay, this one. Okay, now I think you can let's say recognize that a quadrant 1, quadrant 3 is the when a is positive, but when a is negative, what do you think the graph will go? Yes, if you say it's a quadrant 2 and the quadrant 4 will be the graph. So as you can see, this is a quadrant 2, this is a quadrant 4. Now this is the graph will be when a is negative. Okay, so this is all the function that you need to know, okay, about them, which is the linear function, the quadratic, the cubic, the square root, and the rational function. We have one more function that you need to know, which is, we call it, okay, let me go here to the right, okay, which is the last one here, but let's say it absolute value function. What is the absolute value? Absolute, okay, absolute value. What is the absolute value function? From its name, it's absolute value of x. So this is the parent function. Okay, so now what is the formula for the absolute? It's easy function. It's a x minus h plus k. Okay, and the same thing, the graph will look like V letter. It's the same as the, different as the parabola. Parabola is U, okay, smiley, but absolute, it's like V. Okay, so now if I graph this one, okay, so it will be like this one. So it starts from 0 0, okay, goes to the right, goes to the left. So now this one is the absolute value function. Okay, this one when a is positive. Now how about when a is negative? When a is negative, so the graph will go down like this one. So this one when a is negative. Okay, I hope you understand this one, and if you need anything, please tell me. But last thing, how we can graph the absolute value? It's easy way. First you identify h and k. After you identify h, k, you don't have to make table, just look to a. A is like a slope, rise over run. So first you put h and k. Example, let me just let you first, let's say h and k is 2 and negative 3. Okay, so you put the point here, this is the center. Then look to the a. What is a? Let's say a is equal 4. So 4 should always equal over 1, so you have to go 4 step up, okay, and 1 step to the right. So this one will be your graph. Okay, so this one will be sorry. Okay, so as you can see here, this is the center, and you have to go 1 2 3 4 step up, okay, again, because it's negative 3. So negative 3, negative 2, negative 1 0 1, then 1 step to the right and 1 step to the left, then and 1 step to the left, then you can connect your function. Okay, this is how we can. And when a is negative, so we will go 4 step down, 1 step to the right, 1 step to the left, then we connect between the graph. So this is how we can graph all of these function. And if you have any question, guys, okay, please let me know. So this is, we just summarized all type of function, and we just summarized them how we can graph them. Okay, now let's start our lesson.